Assalamu alaikum everyone. My name is Alishehryaar and my groupmate's name is Saud Ahmed. Being an engineer, I believe that at some point in your life you would have thought, how does a certain process works? Like when you see a car running or an aeroplane flying or even a furnace operating, you would have thought, what could be the working mechanism behind this process? Similarly, during breakfast, I thought, how is cup of tea made? No, like I know how cup of tea is made. You add bunch of leaves into hot water and you get tea. But what could be the working principle behind making a cup of tea? On doing a little digging, I found out that the process is referred to as leaching. Leaching is nothing but simply a chemical process that is used to extract valuable materials from solid substances by dissolving them in liquid solvents. Same process happens in our digestive tract. In metallurgical engineering, leaching is used to extract metals. This process is widely used in mining metallurgy and chemical industries. This process is extremely cost effective and has little to none environmental disadvantages. During leaching, the solvent selectively dissolves the desired material, leaving impurities or unwanted components behind. The resulting solution, known as a leachate, is then processed to recover the valuable substances. As you can see here in the figure, when ore is piled onto a container and H2SO4 is passed from it, we get metal extract at the bottom. Metal is screened down in form of a piculate. The leaching column is between the ore pile and the metal screen that separates the hard substances from our desired materials. In this specific example, H2SO4 and Na2S2O5 are used as liquid solvents. Types of leaching. Simply what we have done is divided the types of leaching into four basic classifications based on their ore location, mechanisms where they are based, the vessels on which the principle is based, and leaching that is pressure based. Ore location leaching is further divided into two types: heap leaching and in situ leaching. In heap leaching, ores are piled up in containers. These containers are much bigger in volume, like even bigger than our P block building. And leaching solution is added into these extract volumes and we get the desired metals. The simple working principle of heap leaching is that ore is piled on an impermeable base. When leaching solution, different for extraction of different metals, is passed through the heaps, the percolated metals are obtained, which gets dissolved in the solvent and we get our required metal at the bottom. Applications of heap leachings are commonly used in low-grade ores, especially for the extraction of gold, copper, and uranium. Leaching has quite advantages like it's cost effective and it can be used for low-grade production. It's generally used in remote areas because chemicals can often be very hazardous for local environment. As you can see in the figure, we have obtained three extracts for uranium recovery. Starting from the heap, when acid is dripped onto heap, we get on the collection basin a concentrated solution of uranium and some other chemicals into it. On further refining, we get pure uranium in the drying agent. At the end, I can think you can probably see the container. The challenges that we generally face in heap leaching include the environmental concerns, such as contamination of groundwater and the safety concerns of the workers working there. The second type, based on location, is in situ leaching. In situ leaching, leaching occurs directly in the ore body underground and no excavation is required for it. It simply works by pumping the leaching solvent from one end and then passing it through the ore and then pumping it out from the other end. As you can see in the images. From the left side, the material is injected into the injection well from where it goes into the less underground material ores and is passed through all the ores, extracting the required materials and then it is pumped out of the other borehole. Its application is generally used for extraction of uranium and copper. The advantages of in situ leaching include that it does not require any land disturbance or the transportation of ore from one end to another. But the challenges that it faces are that it can contaminate the groundwater and can have long lasting drastic effects. Furthermore, another example of leaching is bioleaching, which is mechanism based. Bioleaching is carried out by microorganisms that extract the required metals from ores. It is usually done for low grade ores. The working principle is simply that certain bacteria are mixed into ore material and they extract the required metals. Its application is also generally used for extraction of valuable materials like gold, copper, etc. The main advantage of bioleaching is that it does not drastically harm the environment, and it is extremely less energy intensive and has little to no cost. But the challenges that it faces is that microbes may not work efficiently in all ore types. Another type based me- that is meg- Another example of mechanism based leaching is ionic leaching. Ionic leaching basically relies on the process of ion exchange. In ionic leaching, a leaching solution containing ions interacts with the ore, and the valuable metals are exchanged or dissolved into the solution through the ion exchange process. As you can see in the figure, HCl is used as a solvent agent and ionic liquid is placed on top of it. When leaching is done, you get four zones. Different metals are obtained at two zones of back extraction. Liquid liquid is obtained at the bottom and the undissolved residuals that are left of the ore are obtained at the bottom of it. The main advantage of ionic leaching is that it is highly selective to specific materials and can be used to refine them to great extents. But the challenges that it faced is that it requires controlled conditions and cannot be done in open environments. Based on vessel type, another example of leaching is vat leaching. In vat leaching, the ore is immersed in a large vat that is controlled leaching solution, and the metals are dissolved into the solution over time. Stirring or agitation may be used to speed up the process. Applications of vat leaching are primarily used for the extraction of gold or silver or maybe any other highly valuable material. It is an extremely efficient process that is used for higher grade ores and has a better control over the process. But the challenges that we face in vat leaching that it requires a vast infrastructure and has a high operational cost. So that is why it is only used for high grade ores and for the extraction of extremely valuable materials. Based on vessel being used, another type of leaching is tank leaching. In tank leaching, the ore is mixed with a leaching solution, usually under the agitation in a large tank, and the metals are dissolved into the solution. The solution is then drained and the metals are recovered, typically using carbon or any other recovery agent. It's also a very expensive process. That is why it is only used for the extraction of valuable materials. Tank leaching is very fast and efficient way of extracting valuable materials, and you can have better control over the variables and everything is within a tank and can be measured what materials we want to extract. The main disadvantage that tank leaching has is similar to vat leaching, that it's extremely expensive and requires a lot of money. It's also quite energy extensive. The last type of leaching that I will be referring to is pressure leaching. Pressure leaching is simply done by applying high pressure and temperature to the ore. As you can see in the image, the ore is placed in a sealed vessel and a leaching solution is injected under high pressure, typically with oxygen or with an acid. This forces the reaction and dissolves metal more rapidly than under normal conditions. It's quite a quick process and has a fast metal recovery rate. The major applications of pressure leaching are used in the extraction of gold, nickel, or cobalt. Nickel and cobalt are quite difficult to extract using conventional methods. That is why we use pressure leaching. The main challenge that we have with pressure leaching is its high operational cost as high pressured leaching agent is injected into the ores. Now I will move forward to Saud Ahmed.